Hey guys, Mr. Palmer here with another review set of problems from our conservation of energy. This time I'm going to look at questions 4 and 5 from your review sheet. These ones involve the work energy theorem, and I've already placed the work energy theorem equation here, and it tells us that the work done on a system is equal to the change in that system's kinetic energy. And if we're going to calculate something's change in kinetic energy, we're going to get the kinetic energy final, and we're going to subtract from that the kinetic energy initial. It's always final minus initial to find the change. Now this one asks us to find out how much work is done to accelerate a 1,500 kilogram boat from 5 meters per second to 18 meters per second. So we're really looking at the change in kinetic energy. We're not going to be using the work formula. We know that work is force times distance. Well, we don't need to do that. We can simply find the kinetic energy before, the kinetic energy after, and take the difference between them by subtraction. So the kinetic energy final, we're going to use 1/2 mv squared. And kinetic energy initial, we're going to use 1/2 mv squared. So let's substitute in our values. So the final, we're going to have 1/2. The mass in our problem, it's 1,500 kilograms, times the velocity squared. Now the final velocity is 18 meters per second. And remember, you got to square that first. So it's going to be 18 meters per second squared. So we have to do the squaring before we do the rest of the multiplication. I'm going to hit subtract what's minus 1/2. Now the mass doesn't change. It's still 500 kilograms, or 1,500 kilograms rather. And this is going to be the initial velocity. Back up in our problem, it's 5 meters per second, so that's going to be 5 squared. We do the math here. You're going to come out with 224,250 joules. And that's the difference between the final and initial kinetic energies, and that is equal to the work. Okay? Now we're going to apply that to our next problem, which involves a girl riding her bike. And she's going to be getting a push. The push is going to be changing her energy. It's going to make her speed up. So in the problem, it says a young girl's riding her bike at 5 meters per second. She has some initial velocity. The brother's pushing her with 225 newtons. That's a force over a distance of 1.6 meters. And we're looking for the final velocity. It says how fast will she be traveling after. That's the final velocity. Now they also give her her mass here. We're going to need that as part of this problem, her and the bike together. So let's start out with our equation for work. Work is equal to delta EK, the change in kinetic energy, but it's also equal to force times distance. So we're going to start by finding the amount of work that's going to be done. So the brother is pushing her with a force of 225 newtons. The distance is 1.6 meters. So the brother is going to be doing 360 joules of work on her, and that's positive. He's going to be increasing her speed. So let's look at work equal to change in kinetic energy, right? Which is going to be her kinetic energy final minus her kinetic energy initial. Well, one of them we're able to calculate. We can calculate her kinetic energy initial because we said up here she was going 5 meters per second before the brother pushed her. So the work in this situation we already know is 360 joules. That's equal to her kinetic energy final, which we don't know what that is, minus her kinetic energy initial. Well, her kinetic energy initial we can calculate using 1/2 mv squared. And that 1/2 mv squared is going to be 1/2 her mass, so that's 360. I'm going to bring this to the other side. I'm going to add that to both sides, plus her initial kinetic energy, which is 1/2 her mass of 45, times her initial velocity squared, which was 5 meters per second. And that will give us our final kinetic energy of the girl. So if we do the math here, I think her initial kinetic energy is 562.5 is what we get here. We add those together and get 922.5 for her kinetic energy final. Well, we also know that that's equal to 1/2 mv squared. Oop, let me get a different color here. 1/2 mv squared. Well, we already know her mass, that part hasn't changed. So we can say 922.5, her final kinetic energy, is equal to 1/2 times 45 times her final velocity squared. Now you just have to do your algebra. You're going to solve, you're going to need to square root, because we don't want velocity squared, we want velocity, and that will give you the final velocity of 6.4 meters per second. And that makes sense. The brother's doing work, so her velocity should be increasing. Next, I'll be back with some problems that have to do with conservation of energy.